The goal of this video is to answer the question of what is a light year, explain why we use it and some of its applications. A good place to start would be looking at the definition of a light year. So a light year is the distance light travels in one Earth year. So breaking that down, we can see that I've underlined the word distance to emphasize that a light year is a measure in distance and not in time. I think to fully appreciate the scale of a light year, firstly it would be good to understand the scale of the speed of light. So the speed of light is equal to 299,000,000 meters per second. So we'll keep it in the SI units. So for every second that goes by, photons of light will travel 299,000,000 meters. So to round that up, what's usually used in textbooks is 3 by 10 to the 8 meters per second. So it's roughly the same. Now what we're going to do is we're going to do a little experiment that will show the magnitude of a light here using the information we just gathered here on the speed of light. It'll give you a bit better understanding into the nature of the sheer magnitude of a light year. So what we're going to do is we're going to begin with light source here, this little red light here. This could be a laser, something that just emits photons, and we're going to have it emit photons just in one dimension over here. We also have a stopwatch that's at 0 seconds at the moment. Now once I start the stopwatch, I'm going to emit a photon from this light source. So if I begin the stopwatch now, this photon just travels in this direction, minding his own business, and then after 1 second, I'm going to stop the photon. So at 1 second, I've stopped the photon. Now I want to know what distance this photon has traveled in this 1 second. Well, as we set up here, we defined the speed of light. C is just the notation for the speed of light. It is 3 by 10 to the 8 meters per second. Well, our photons just traveled 1 second. Therefore, the distance it's traveled must be 3 by 10 to the 8 meters. So that's the distance that this photon has traveled. So it's the distance that the light has traveled in a second. So you could also call this distance a light second. All right, well, suppose we don't stop this photon here after 1 second and we let it go. We just keep it going. So we started the stopwatch here and the photon just continues. This isn't going to be a linear scale, as you'll see in a minute, but I think you get the idea. Now let's say after 60 seconds we stop the photon. From here, the distance traveled from here to here, well, because it's a photon of light and because it's traveled for 60 seconds, we can then call this a light minute, as it's the distance that the light has traveled in 1 minute. And that distance, for interest's sake, is 1.79 by 10 to the 10 meters. So extremely large value. But the principle here is not so much the numbers, but more the understanding that the photon travels 1 light second in 1 second, and then in 60 seconds, the photon has traveled a certain distance in 1 minute, and it's photons, so we're referring to light, so it's a light minute. But again, to remember, the light second, it's a distance measurement. The light minute is also a distance measurement. That's the key point. So then just following on from this logic, we just keep this going, and say this was the 1st of January and we start the stopwatch, and then we hit February, we hit March, and this photon just keeps going in this direction, all the way around to the end of December, and we stop it here. So this is after 1 year. So this photon's been traveling for a whole year just in the one dimension. And then this is what we call, I don't know where I'll draw it. I'll draw it here. So it's gone all this way. And this distance, remember the distance is called a light year, because it's the distance that this photon has traveled in a year. Now, so I just with this green arrow, this just denotes the distance that the photon has traveled in one light year. So or in 1 year, and that distance roughly is 9.5 by 10 to the 15 meters. To put that in perspective, just for why not, that's going to be 9,500,000,000 meters. So safe to say it's quite a distance. Now this is where, so hopefully that makes sense. Now this is where we get into, well, what is the point of this? Like, why do we need to know numbers of this magnitude? This is where as I mentioned at the start, where we talk about a little bit about the applications of a light year. Why do we need measurements or units that are of this scale? It doesn't seem necessary. An example of where we do need these units or constants of this magnitude, we don't have to look any further than our galaxy, the Milky Way, and the distance to our neighboring galaxy, Andromeda. So the distance between the Milky Way and Andromeda is 2,537, so 2.5 million light years. So not 2.5 million meters, so 2.5 million of this. So you can see from this example, and just to remember that this is our closest neighboring galaxy, let alone the other side of the observable universe. There are a few other different measurements of distance. The parsec is one which again, it's used to measure distances outside of the scale of the solar system. And then you have an astronomical unit, which is roughly the distance between the Earth and the Sun. So there are these larger scale measurements that are used when needed. I think to finish this video, it's more of hopefully now you guys understand what a light year is. It's interesting when you think of light as something traveling from A to B, but that's really what it is. Just because it seems instantaneous, we always just kind of think of it as there's light there, there's not light there. Whereas it's a traveling set of energy particles called photons. And a fun kind of thought experiment, which maybe some of you have heard, is if we have, so this is the sun over here, and on our little green planet here. So we have this distance here, which is roughly 1 AU. That's what I just said a minute ago. Astronomical unit is the distance from the Earth to the Sun. And once a photon is released from the surface of the Sun, the amount of time it takes to hit us is about 8.3 minutes. So then if I said to you to put it in terms of a light scale, let's say, you would then say that, well, because it's photons, because it's light traveling from the sun, you would say that the distance from the Earth to the sun would be 8.3 light minutes. So essentially what that says is everything we're looking at is in the past, which I think is going to be a different video because it's a very interesting topic, but anything that you see is the result of photons coming into your eye, which have traveled some distance and therefore taken time to reach us. So if the sun exploded at the instant that you're watching this video, you won't know for about 8.3 minutes. The same with anything like that. It's just something to think about. It makes you look at these things in slightly different in a different reference frame. But yeah, that's all for this video. I hope I answered the question of what is a light year. Kind of explained it in a coherent way, although some parts I'm not sure if that was the case. But anyway, if you could like the video, I don't know, even share it to your friends, subscribe. It would be much appreciated. Try to get the channel out there. Generally, I do maths videos, but I'm starting to do physics videos as well. This is only my second physics video I'm doing, but I'll build on that. Hope you enjoyed it, and we'll see you in the next video.